Basic electrical learning.
The resistivity of copper, like any other material, is typically measured using a technique that involves applying a known current through a sample of the material and measuring the resulting voltage drop across it. Let's see how it happens. A uniform, cylindrical, or rectangular sample or cube of pure copper is prepared. The length L and cross-sectional area A of the sample should be accurately measured. A stable and known current I is passed through the copper sample using a current source. A voltmeter is connected across the sample to measure the voltage drop V that occurs due to the current passing through it. With the current I flowing through the copper cube or the copper sample, the voltmeter measures the potential difference V across the length of the sample. For example, the current flowing through the copper cube or sample is 10 amperes as shown on the current source, and the voltmeter is showing 0.1724 microvolt. Now calculate the resistance of this copper cube. The resistance R of this sample is calculated by using Ohm's law. R is equal to V over I. Now let's put the value of voltage that is 0.1724 microvolt divided by the value of the current that is 10 amperes. Now by calculating with the help of calculator, we found that the value of the resistance R is 0.0000001724 ohm. Resistivity ρ can be calculated using this formula. This formula can be rearranged for the calculation of resistivity ρ. So now the resistivity ρ is equal to R multiplied by A and divide by L, where R is the resistance of the copper sample, A is the cross-sectional area of the sample, L is the length of the sample, and the measurement of the copper cube or copper sample is area A is equal to height into Wyerth is equal to 1 meter, multiply 1 meter is equal to 1 meter square, and the length L of the copper cube is 1 meter. So, by putting the value of resistance, area, and length in this formula and solving the equation with the help of a calculator, we found that the resistivity of this copper cube is 0.0000000174 ohm meter. This is the resistivity of copper at 20 degrees centigrade. Resistivity is temperature dependent, so measurements are typically taken at a standard reference temperature, usually 20 degrees Celsius. Corrections may be applied if the sample is at a different temperature. So, at standard temperature, the resistivity of copper is 0.0000000174 ohm meter. Or the resistivity of copper is 1.724 multiplied by 10 raised to the power of -8 ohm meter. This method provides the resistivity of copper, a fundamental property that can be used to understand its electrical conductivity. This method can also be applied to other metals like silver, copper, gold, and aluminum. First of all, find out the resistance of metal with specific dimensions. For example, a metal cube of any material with a 1 meter length from all sides. Find the resistance by using a multimeter or directly ohm meter. Then put the value of resistance in the resistivity formula. After calculation, you will get the resistivity of that metal. Remember the resistivity shown, for these metals are at a standard temperature that is 20 degrees centigrade. The resistivity of any material is a fundamental property that can be used to understand its electrical conductivity. Here is a table of materials displaying their resistivity and conductivity at standard temperature.
Basic